Dr. Muhammad Ali. My publication, my name is Muhammad El-Hadedy. I'm Associate Professor at the ECE Department at College of Engineering at Cal Poly Pomona. The idea of ionic thruster is really quite simple. We'll try to use the difference in the charge between the collector and the emitter for generating ionized area between of them that will be pushing the molecules of the air enough to create the thrust that it will help for moving and mobile robotic elements.
Hi, my name is Justin Arias. I am a fourth year. I graduate this year, 2025, from Cal Poly Pomona. When I describe it to my peers or anyone that asks, it's a high voltage source project where we take a emitter with high voltage and a low potential collector to collect the charged ions. And in between these two components is neutral air that will act as a resistance. And we're basically creating a wind effect with this high voltage source.
I mean, it's cool that, the undergrad students involved in this project, they learn a lot for different aspects. They learn from the electrical part, they learn from controlling part. As you know, you guys already built a very nice, sophisticated microcontroller system that it will be directing the emitters to the collectors, and then on top of that, looking into the console, which is a software for physics, deciding, based on this, the dimensions needed for the best collector. I mean, I have a bunch of other projects, but this one is really quite cool because I'm aware that NASA is working with radiation thruster. It's infeasible to do it on Earth and even with whatever materials and limitation or budget we have. So that's why we decided to go together with the team for the ionic thruster, hoping that in the future we will have an access to the radiation thing, that we can go into the radiation thruster.
I'm Rohan Sampur, and I'm currently a fourth-year electrical engineering student here at Cal Poly Pomona. My job in this project was to work on researching argon and testing it out with our design. We decided to use argon due to the fact that it's more cost-effective than xenon. It also has heavier ions than most gases, which is perfect for our project. Additionally, it provides the perfect proof of concept without the use of a vacuum chamber.
Hi, my name is Juan Trejo. I'm a fifth-year electrical engineering major here at Cal Poly Pomona. My role in the project was to research transformers in order to get the highest voltage and lowest current possible in order to get the best results. We were focusing on having a lightweight transformer, but some of the problems we were having with that was that we were getting a voltage drop at 5 volts, which was limiting our output. So we are now focusing on results. In order to do that, we're kind of going to drop the idea of being lightweight, and we are going to look into possibly getting a more powerful transformer that's able to handle a higher voltage and a higher current in order to make that possible.
Hello, I'm Hevida, and I'm an electrical engineering student. I contribute to this project by setting up simulation environments in console multiphysics. One of our goals is to find an optimized geography for the collector and as well as the emitter electrode. So by simulating the properties and geography of these electrodes in the simulation environment, we can better visualize the output wind, the thrust from the collector, and then the electric field in the region between the two electrodes. Currently, we are incorporating some magnets into our design so that it helps propel the ions towards the collector and in turn achieve more thrust.
Also, the magnets is something really interesting to use, but as you can know that we are limited on all the resources. Plus, safety and reliability is one of the aspects that we are respecting at the moment. The whole entire idea is to figure out what is the feasibility and study the whole entire concept of generating enough charge that it will be breaking the resistance of the air within the collector and emitter in a way that we can figure out what is the possibility for designing the collectors, what materials used for designing the collectors, and what flying or moving elements that they can benefit from such a kind of thing based on the limitation of the budget. I see there is a big potential for even building a flying elements. It could be helicopters, for instance, having a bunch of this ionic thruster part, or even building a massive number of collectors that it will be directed with emitter in a way that it will be getting all of the push of the particles in a certain point, and also feasibility of studying the movement of the emitters in front of the collector in a speed enough so we can clear the wave of the ionization between of them. It's a generation of Artemis, the new generation of the students is actually like, pushing all the boundaries of technology. And this is one of the possible projects that I really like. Even myself, I try to build my own in my office. Students actually really learn to build 3D modelings using resin printers, thinking about, the connectivities of material. That's actually make me happy because, electrical part went through the computing parts to build something more important, which is a system. So I really, really love this project.
It's a fun project, very limited research. There are maybe 2 valuable sources online that we can use, and that's the research from MIT, which is very limited, although they do share their designs, and some research papers with NASA actually.